Hi, good morning. Today we're going to continue with the related rate problem. Question 1. At a certain height, a tree trunk has a circular cross-section. The radius RT of the cross-section grow at a rate modeled by the function dRdt, and t is between 0 to 3, where t is measured in years. At t equals 0, the radius is 6 centimeters. The area of the cross-section at time t is denoted by A of t. So let's take a look at what I mean by a tree trunk. So if the tree trunk, you chop it, look like this, and then you cut it this way, then you will see a circular shape over here. And this is called the cross-section. So this is the cross-section. And the radius is r. R is r of t. The radius is a function of time because as the tree grows bigger, then RT change. And then the areas also change as the time pass. So therefore, it's also a function of time. So now we get R prime of t, which is dr dt. Two different notation. Okay, so we have this given to us. So when we read this, we found out that at t equals 0, the radius is 6. So by the time that you observe, the radius already is 6. And now we're going to take a look at part A. Write an expression involving integral for the radius RT for the time interval 0 to 3 inclusive. Use your expression to find R3. So we have to find R of t, and we know R0 equal to 6. And R prime of t is given, and we have to use it to find R of 3. So you have entire derivative and derivative given to you. So the first thing you should think is the FTC. So we're going to use the FTC. So let's review what is FTC. So this FTC, so you have integral a to b f prime of x dx. We give you fb minus f8 derivative entire derivative. So I want to have the r of t, and I had r at 0 equals 6, and I have r prime of t. So I just have to do 0 to t, a to b, 0 to t. So r prime. I cannot use t, I have to use x. So now I get r of t minus r of 0. So this using the FTC in different notation at prime, r prime. So now I am going to substitute. I get 0 to t. My r prime is this. So I'm going to write 1 over 16. I cannot use t, I have to use x. And then minus 6 because r0 is 6 plus 6. I'm going to rewrite it. So now I got my RT, the integral expression involving with the R prime. So now I'm going to use my R of t to find R of 3. So I just substituted t by 3. Now I'm going to type in this in our calculator, and then you get R of 3. So the best way to do it is make your y1 equal to the dr dt, which is 1 over 16 of this. And then do integral. And then you type into that. You do math 9, 0 to 3, y1 dx plus 6. Then you will get 6.610847658. I'm going to leave my answer this way because the question never asked me to round. If you want to round, you can round to 3 digits to the right side. So now we're going to part B. Part B asks you to find the rate at which the cross-section area AT is increasing at t equal to 3. So part B, so the question basically asks you to find the rate of A of t at t equal 3. That means you have to find A prime of 3. So the question never give you the function like this directly. Okay, you don't have a model for the A of t, so you only can rely on the area formula of a circle. Okay, so you had A equal to pi r squared. That's the only formula can relate A to the r. So now we have A of t equal to pi times big RT squared. I use big R because the question gives us big R. So one more time, the only equation can relate the big R to A is the area formula. So now we're going to find the derivative using chain rule. Bring the 2 to the front, exponent become 1, so you put RT, and then you're going to write the derivative, which is R prime of t. So we use chain rule over here because you have to find A prime 3. So therefore, we put A prime 3 and we do substitution. So we already found R3 in part A, so we just have to find R prime 3. So to find R prime 3, you use the RDT, which is your Y1. So you do Y1 of 3. In other words, you substitute 3 into this function. You put 1 over 16 times 3 plus sine 3 squared. Okay. So since we're allowed to use calculator, I get my number y3, which is r prime of 3, equal to 0.2132574. So now I'm going to do substitution over here. Okay, so from the previous part, I got 6.610847658, and then times the 0.2132574. Okay, so I already have it in my calculator, so if I'm going to type it in, so we're going backward, times 6.610847.658, and then times 2, and then times pi. So I will get 8.85811. And then because this A prime is two-dimensional, so the unit should be centimeters squared per time, and the time is year. So we finished question 1B. Now let's take a look at 1C. 1C, the question asks you to evaluate this integral and using appropriate units, interpret the meaning of the integral in terms of the cross-sectional area. So we got integral 0 to 3 a prime t dt. I believe at this moment you already know that we should use RTC. We don't have the modeling equation for a prime t, and we don't have the graph. We don't have the table. So the only thing we can do is a of 3 minus a of 0. And you can find a of 3 and a of 0 because we know that a equal to pi r squared. So a of 3 equal to pi times r3 squared. And we know r3. So r3 we found that is a decimal. And then we also know how to find A0. This is the same concept. So we do R0 square. So you have the 6 equal to R0. So now we can type in this in our calculator and subtract. And then we will get our A of 3 minus A of 0. So we got 24.20065. So we got 24.20065. Okay, so now area, subtract area. So definitely is square centimeter. So now after we found the value and the unit, now we're going to explain. So we had done a question like this before, so it means the change in area, because A of 3 minus A of 0, that's the difference of area, so it means a change of area. So it represents the change in area of cross-section from t equal to 0 to t equal to 3. And because you get 24.20065, a positive, you can make it more specific. So the area of cross-section increases 24.20065 square centimeter in 3 years. You can say from t equal to 0 to t equal to 3 years. So we finished question number 1.